Okay, let's try again. And we are going to use our identities to verify expressions um, and verify expressions for all angles. So we have this expression cosine of theta divided by sine of theta cotangent of theta is equal to secant of theta times cosine of theta. So what I want to do when I look at this is again rewrite both left and right in terms of sine and cosine. That's the most logical thing to do. I noticed the left is one of those fractions that could end up being a super fraction because I got cotangent in the denominator here. So what I want to do is split this expression apart. I'm going to pull out the cosine in the numerator, put it in the front. So this is just the cosine of theta, and that's going to be times 1 over sine of theta times the cotangent of theta. And that's equal to secant of theta cosine of theta. Now, the next step that I want to do is when I'm looking at this is another like double expression here. So we can pull that apart. So I want to rewrite that as two fractions. So I got cosine of theta times 1 over sine of theta times 1 over cotangent of theta. And if I look at this now, it's easier to rewrite everything in terms of sine or in cosines. So the first one, cosine of theta, is just cosine of theta on the left. 1 over sine is still just 1 over sine theta, because that's good. The next one, though, 1 over cotangent. 1 over cotangent, remember that is also the identity for tangent. Tangent is, the reciprocal for tangent is cotangent. So 1 over cotangent would be tangent, and we know tangent is just the sine of theta over the cosine of theta. And another way to think about that is, I know the identity of cotangent is cosine over sine. So if I'm talking about the reciprocal of that, or 1 over that, I would be flipping that and it would be sine over cosine. Okay, so now let's look at the right. The right side is secant of theta times cosine of theta. So I'm going to change secant to 1 over cosine of theta. And of course, that would be times cosine of theta. Now, guys, if we look at this to the left, you could combine, we can multiply these two together, these two fractions. I would have cosine of theta times 1 over sine of theta, right? Well, that would just give me, and I'll put the result down here, I would have a cosine of theta over sine theta. And that would be times a sine of theta over cosine of theta. And notice when you multiply those out, the left would actually, everything would actually cancel out, right? And I would end up with a 1. Okay, so let's see if the right side, the same thing happens. Well, with this one, I would end up with cosine of theta over cosine of theta. And notice that also equals 1. So this expression indeed is equivalent to the left and the right, which means it's verified for all identities.